Okay, so we are starting a new unit on polynomials and factoring. So our first lesson is a lot of vocabulary so that we have a really good basis with the words that we're going to be using during this unit. And you need to be able to understand exactly what I'm referring to throughout the lessons during this unit. So go ahead and title this Polynomials. And we're just going to get straight into um, vocabulary. So a polynomial is an expression that is the sum or difference of terms of the form ax to the k, where k is a non-negative integer and a is a real number. Okay, so that's polynomial. Now, the thing about these words, there's monomials, binomials, trinomials, and we'll get into kind of each of those as well, but polynomial covers all of these. So that's why it says where k is a non-negative integer. So as long as k is 0, 1, 2, 3, or any positive integer beyond that. Okay, so next up is standard form. Now this is not the same standard form that we talked about with graphing. A lot of different things that you'll see have a standard format, and this is just the standard format for polynomials. Okay, so this in standard form, the polynomials are written with the powers in descending order. Okay, so what you'll notice is, let's say we had all x's. So if we had 2x to the 7th minus 3x to the 5th plus 7x squared minus 4. You'll notice that our x have different exponents, and our exponents are in descending order. Has nothing to do with the coefficient, it's all the exponent. Okay, so this would be a polynomial. And that's not just because they're in descending order. If you look at our exponents are all non-negative integers. Okay. Here's an example of what's not a polynomial. Okay, this is not polynomial. And the reason it's not a polynomial is that I have negative exponents. That's going to have a negative exponent, and this is a problem as well. If I were to rewrite this, this would be rewritten as 3 times x to the negative first power, which is a negative exponent. That's a problem, right? Okay, so the minute you see a negative exponent, it's not a polynomial. Unless somehow, you have something crazy here, and if our x had a negative exponent here, I could move it up to the top and make it a positive. So in that case, it would be a polynomial, so kind of keep your eye out for that. But I would guess that that's not going to happen a ton. Okay. Next word, or next vocabulary term, degree of term. If one variable then it's the value of the exponent if more than one variable it's the sum of the exponents. Okay, so this is for determining the degree. So if you only have one variable, then the degree is the value of the exponent. If you have more than one variable, it's the sum of the exponents. And that's the degree of the term. So each term can have a degree. The whole polynomial could also have a degree. Okay, so here's an example for the term. So in this case, it's a 7th degree term. So then if I also had negative 4 x to the third y to the fourth. Now if I have more than one variable in my term, it's the sum of the exponents. We don't actually add them and get something different, but when we're looking for the degree, this would be the 7th degree term also. The reason this is important is because depending on the degree that you have of the highest term, that determines the degree of the whole polynomial. Okay, so now let's look at the definition of degree of polynomial. Okay, so the degree of the polynomial is the degree of its highest term. Okay, so you find the term that has the highest value, highest degree, and that's the degree of the polynomial. Okay, so for example, and this is why we put the numbers or the terms in order by exponent, because then we look at the very front. And we can look at the front and use that exponent to determine the degree. So if I look here, 3 is my largest exponent. So that tells me it's a third degree polynomial. And that's why it's important that we have an order, right? So the next word is actually going to connect up to here as well. Leading coefficient. So leading coefficient is coefficient of the first term when written in standard form. And remember, standard form means that it's that specific order where it goes from highest exponent to the next highest to the next high, it goes from largest down to the smallest exponents, right? And this 4 right here would be considered the leading coefficient. Okay? So it's the coefficient that leads the whole polynomial. So that very first term is very important. It gives us our leading coefficient and it tells us what degree the whole polynomial is. All right, so there are classifications of polynomials. We're going to look at that next. So polynomials are classified 2 ways. One, by their degree, and by the number of terms. Usually you'll see them named by the degree, but we'll get to that too. We're actually going to get to that right now. So if we have a polynomial to the 0 degree, it's called a constant. Now remember, anything to the 0 degree is 1, right? So again, anything to the 0 degree is 1. So, for example, don't write this down, you could just look. 3 times x to the 0 degree. Well, x to the 0 is 1, so it's really 3 times 1, or 3. And if you notice, with many of the problems that we've been working with, especially when we were graphing, there were variables and there were constants, right? When we had, y equals mx plus b, the 2 would be the coefficient, but the 3 would be the constant, right? It's the number that didn't have a variable with it. Constant. It's when the variable has a 0 power. So there might have been a variable with a 0 power. It's just that when it's 0, the value is 1. So that's a constant. So some examples would be -4, 2/3, 6. Those are all constants. And that would mean that if there was a variable, the exponent was 0. Then we have 1. And if the exponent is 1, we're dealing with linear equations. Okay? A linear equation looks like this, right? Y equals 2x plus 3. Well, if we look at the variable or the exponent of the x, in this case it would be 1, right? And that makes a linear equation. So an example of linear expressions, or polynomials in this case, would be 3x minus 4, negative 2x. So as long as wherever the variable is, the exponent is 1, it's linear. It's going to create a line. That's similar to what we looked at when you were comparing linear equations to exponential equations, right? So next up is when the exponent is a 2. And this is called quadratic. So anytime you have a quadratic expression, our exponent is 2. So here are some examples. Okay, so x squared by itself, quadratic. If I want to look at something a little bit bigger, negative 3x squared minus 6x plus 2. If you look, my exponents are written in order, 2, then 1, then this would be x to the 0, right? And that's quadratic. And that's actually what we're working our way into, our quadratic equations. Next up is when our exponent is a 3, and this is cubic. And some examples would be 2x to the third, x to the fourth minus 4x. Excuse me, not x to the fourth, sorry. X to the third, make sure that's a 3. So x to the third minus 4x to the second, that would be example of a cubic. Fourth is quartic. These cubics and quartics are something that you'll find later on in your algebra classes. Okay, but this is when we have x to the fourth, 2x to the fourth minus 3x would be another example. To the fifth power, we have quintic. And we've got an example would be negative 3x to the fifth minus x squared plus 2. And I believe as of right now, we go up to the 8th degree. And it's something that I guess is pretty intense when it comes to mathematicians. It's something you can kind of Google. It gets pretty interesting, but for the next near future, you probably won't need much past this. But we're going to write down one last line. N would be an nth degree polynomial. Basically, what that's saying is if you had a degree of 8, you just say 8th degree. If the highest exponent was a 10, you'd say 10th degree. So for example, if you had, 2x to the 9th would be 9th degree polynomial. That's all that means. Okay, and that's it for right now. We just wanted you to get some basic definitions out of the way so that we can start adding and subtracting tomorrow and multiplying, dividing, and doing all of that. That's it. Last thing that you will be asked to do is to classify by term. So okay, so you'll be asked to classify by the degree, which we just covered. And now for classifying by number of terms, you literally will take a look, make sure that there's nothing to combine. For this first day, you won't have to worry about combining like terms or anything like that. You literally just take a look at how many terms are in your expression. And remember, the term is the coefficient and the variable. That's a term. Okay, so in this case, I have 1, 2 terms. So to classify by number of terms, just say 2 terms. Okay, if we have 4x to the third minus 7x plus 3, we've got 1, 2, 3 terms. Sometimes you'll hear it say second term or third term, same difference. Remember, even if it's a constant, it's counted as a term, okay? And if you had something as simple as just 3, would be 1 term. And that's it.